Go ahead.
All right. Hello, everyone. I'm Jed Retherford. I work for National Instruments. I've been helping out with these first robotics preparation sessions for the last couple of years. So, tonight they'd asked me to talk a little bit about the control system in LabVIEW, and I think I have, somewhere around an hour to do that. So I am going to do my best to give you a little bit of a taste of what you need to learn about LabVIEW and the control system during that hour. I can't possibly get all of the information that I'd like you to in the amount of time available, and so instead of trying to rush things, I've actually put together a web page, with a couple of my coworkers, where I'm going to link a bunch of content for you to follow along on your own. I hope to do some additional live sessions in the future. But to start off this presentation, I'm just going to throw this up on the screen for you and just say that they just put together this nice short link, so it should be pretty easy to find. But ni.com/mnfrc. I'm going to go ahead and suggest that you go and register either now during the meeting or after the meeting. I'll put the link up a few more times. And so if you guys, if you have, go ahead and head to that page. I'm hoping to put up about 6 sections of content. I've got 2 of them up right now. In fact, I guess I can probably jump on my screen to, let me see if I can find my web browser quickly here. Maybe not. Yeah, there we go. So this is the page here, ni.com/mnfrc. And what you can see here is I've got a main thread and then 2 sections of content that you can download. And so these are some things that I'm going to suggest that you follow on after we're done with this presentation tonight. In addition, I will post all of my slides here, in addition to sharing them wherever they need to be shared. But I just want to put that out there for you. So let's see. I'm getting something flashing at me. I haven't done this before. Do I need to know anything about? Are you guys not seeing what I'm doing here?
We're good.
You're good. All right. Sounds good. So, my objective tonight, I've got, like I said, in about an hour, is to just familiarize you a little bit with the FRC robot control system, give you a basic overview of the LabVIEW environment, and provide you with resources that are going to allow you to learn more about LabVIEW. But mainly, I want you to remember that, your goal still is to have fun, and that's kind of the goal. Software is a good, software could be a cumbersome topic at times, but one of the nice things about LabVIEW is it is pretty easy to use, and so hopefully you guys will see that as we go through this. Very quickly about the company I work for, National Instruments is a major sponsor of the FIRST robotics competitions. We donate thousands of hours a year of our time to FIRST. But mainly I just wanted to kind of mention it quickly because if you're not familiar with National Instruments, they provide one of the programming languages, LabVIEW, and the control system for the robot. And it's just kind of it's a company that's now 6,000 employees worldwide, but it's one of those great American success stories that started, from just one person. The important part I think I like to point out is that it started in a garage. Because all great technology companies start in a garage. It's one person who's got another job just kind of working on something else. Google started in a garage, Hewlett-Packard started in a garage, Apple started in a garage. So I kind of like to put it out there for you as you're preparing and starting to go through this. Someday, any one of you out there could eventually be leading a company that employs thousands of people. That hopefully that started in a garage at some point. And so with that, as just a quick background on the company that I work for, I just want to go over the control system first, and then we'll move on to LabVIEW. We'll spend more time on LabVIEW than we do on the control system. So the FRC control system is in, I believe, its 4th year now. It is based on a product called CompactRIO that my company, National Instruments, manufactures. It is light years ahead of the control system that was being used prior to it. It has an awful lot of power as robotics control systems go. It's quite a bit more advanced than a lot of things that are on the market today. And the nice thing about it is if you have been a participant in the tech challenge before, the software that you would program, that would be used to program the Legos in the tech challenge is exactly the same LabVIEW that you can use to program your FRC robot as well. So this, as you look at just kind of an example robot here, this, I don't know if you can see my mouse or not, but this piece up in the upper right-hand corner, this CompactRIO Controller, is the part that we make at National Instruments. It's the part I'm going to be talking about programming tonight. Controller plays, obviously a huge role in the in the robot. It is probably the single most important thing to what the robot does. It's going to help you. It's going to take care of the two major stages of the competition: autonomous mode and teleoperated mode. Autonomous mode, it's doing everything. In teleoperated mode, it adds the additional function of taking driver station input and then giving feedback to the driver station in order to control the robot so that your driver can control the system. So the controller plays an absolutely huge part in what you do. Since autonomous mode is on the screen here, I am going to point out that some of the links I'll be posting later that aren't up yet are definitely going to be about autonomous mode. In general, we haven't seen a ton of people taking advantage of autonomous mode, and this controller certainly has the power to do that. So I'm hoping, I don't know what the challenge is yet, but I'm hoping that this year we'll see a lot more of the teams take advantage of autonomous mode. This is kind of the basics of the controller. It is, the ones that all of the veteran teams are going to have are going to look pretty much like this, where they've got the 400 megahertz processor, embedded RAM, and embedded flash storage. Got dual Ethernet ports, and it's a very rugged controller. You're going to have a tough time breaking this if you don't do something like get metal shavings or dump water onto it. It's an extremely rugged controller that should be able to survive anything that's going on in the game. The three major modules that you're going to see, I think, everyone's probably using are the 9201, the 9403, and the 9472. And they are an analog input module that allows you to bring in analog measurements, and then a low voltage and a high voltage digital module. Important to note, these need to be in the slots that they've been assigned for. And so you need to be sure to keep the modules in your control system in the slots where they were assigned. The reason why is the backplane of this controller actually comes pre-programmed, or when you image the controller, we reprogram the backplane for you. It's one of those things that outside of competition you can take advantage of programming, but for the competition, for things like safety systems, we make sure that the backplane image is the same on all of them, and so the modules need to be in the slots that they're in. The controller is able to be programmed in three languages as of last year. Prior to last year, it was just two languages, C and LabVIEW. Java was new last year. You were able to do wireless debugging, and there's a laptop dashboard to allow you to see what's happening on the robot. Regardless of which language you use, C, Java, or LabVIEW, the laptop dashboard is still going to be a LabVIEW panel. So even if you're not sure if you're using LabVIEW, you're still going to become familiar with it via the front panel or the dashboard view that you see there. In the state of Minnesota, the LabVIEW has been the dominant language. Last year, between like 70 and 75% of the teams programmed in LabVIEW. The year before that, when Java wasn't available, it was more like 85% of the teams that programmed in LabVIEW. So in general, I think you're going to find the most resources available for LabVIEW. And obviously, as a sponsor of First, National Instruments donates a lot of time trying to bring up to speed on LabVIEW. So it's just something that, it's something that that's going to be out there. Real quickly, I'm hearing a lot of beeping in the background. Are those questions for me, or do I need to switch over to a view where I can see questions pop up?
We'll let you know if there are questions. There is a little bit of a problem with them seeing the slides, but we are getting a good signal here to record.
Okay, well, great. Why don't you, Chris, I'll just put it on you to interrupt me if major questions come up that seem like they need to be answered immediately.
I will do that. Thank you.
Sure. So the basic idea of how your robot gets programmed are you're going to develop on a laptop, and I'm going to take this opportunity to say that if you have the little mini driver station notebook. I really don't recommend programming with the driver station notebook. The processor inside the driver station notebook was basically designed to run in a cell phone. And so you would probably never try to program your robot from a cell phone. And so just think of it that way. If it's the only computer you have, it can be done. But I've seen more problems with that driver station notebook being used for programming than with just about anything else. So I really recommend getting a desktop or a laptop PC other than the driver station notebook to do your programming. Once you've programmed your application on the computer, you're going to download it to the CompactRIO, either via a cabled connection or via a wireless bridge. And then at that point, your robot will be set to run. It will be set to run on its own. So the driver station will still get updates, but at that point, all of the code that's controlling the robot will actually be embedded into the robot itself. So a quick heads up, there is a new controller for 2012. It's remarkably similar to the old controller, but it is smaller. That does make it lower cost, which makes if you want to buy a second one, a little more viable. If you are a new team, you're going to be getting this slightly smaller 4-slot controller instead of the older 8-slot controller. Veteran teams will continue to use their old controller. We're going to continue to support both controllers for the long haul. But this one's a little lower cost, and so as a result, we're able to lower the price that teams can buy an additional controller at each year. And so in the past, a new controller with 3 modules was $750 if you wanted to add an additional, if your team wanted an additional one. With this new controller that's available now, you can get the new controller and 3 modules for $525. So if you do want to keep an old robot intact, or if you want to be able to develop a robot in tandem with the one that you're working on this year, if you have funding available to be able to add this additional controller, this is an awfully nice option. The $525, just to give you an idea, is probably about 1/5 or 1/6 of what this setup would normally cost if you were buying it in industry. So it's a very reasonable price. We're trying to get that out there to you if you want a second controller. This is a website, and as I said, I'm going to post this. This is a website with details about this new controller with frequently asked questions. And if you do want to order a second controller for your team, here is a number from this web page that you can call during normal business hours, which I guess officially it is normal business hours at National Instruments for another half hour. So if you really want to order a controller right now, I guess you can. That'd be a number you can call if you want to get a new controller. Any questions at all about this new controller for 2012? I'll jump over and just peek. Okay, so no, doesn't look like it. All right. And so with that kind of ends my section on the controller. I didn't do a lot of time on it. I will be posting some applications or some links that are going to kind of cover in depth what will and won't work with the controller. And that should work well for helping you come up to speed on using it if you have not used it previously. All right. With that, let me move on here. All right. So Chris, I'm noticing that they're commenting about presentation issues. Would it be better if I dropped the video off of my presentation?
I've asked them to do that when they want to do that. Those that can get it, we should be okay.
Okay. All right. All right. So with that, let me move on to LabVIEW. So I have like 40-ish minutes to give you kind of an overview of LabVIEW. In general, my general take is that somewhere around the line, somewhere in the lines of like 5 to 12 hours is probably the amount of time that you're going to need to spend to become reasonably familiar with LabVIEW. And so, just to kind of preface it, I'm going to give you some very basic parts of LabVIEW, put them out there for you, and hopefully just get you a little bit more comfortable opening LabVIEW, using it just a little bit. But then afterwards, I'm going to point you to that web page that I had up earlier, and try to get you to follow up with some additional training on your own. Because I think that training is really one of the things that you can be, software training is one of the things you can really be working on ahead of time. So the couple things to keep in mind, this is, learning about LabVIEW is one of the easiest things to work on before the build season. On this web page that I've linked to, I'm specifically breaking it down into two different sections, a section that can be worked on without the robot present, and then a section that can be worked on with the robot or with just the CRIO around. And so you should be able to follow along pretty well, through that. And then as soon as your CRIO becomes available or your robot starts getting built, you'll be able to move to the things that do require the robot. This is, 5 hours I would say is probably minimum. 10 to 20 hours is probably, the amount I would say for real success. And so I guess the way to think of this is if you're willing to put in, 5 hours before winter break and then another 5 hours over winter break, by the time your build season starts, you should be in great shape to do a really nice, modification and LabVIEW programming. If you put more time in, it's just going to be that much easier once the season starts. So let me start with an introduction to LabVIEW. So the question of, I know you'll get a choice of programming languages, so why use LabVIEW? And this is an example that's a little dated at this point. This is actually probably 5 years old now. But this is one of my favorite examples of why I think LabVIEW is such a powerful language. You may not be familiar with the DARPA Grand Challenge, the Defense Administration Advanced Research Projects competitions. Has issued these grand challenges over the last few years, and a number of them have been based on autonomous vehicles. The first one was a drive through the desert. And so Virginia Tech had a relatively small team of 6 students and a geology professor, and they used a CompactRIO, the same exact CompactRIO that you're using for this first robotic competition. And then MIT, a rather well-known university, had 20 PhDs working on their project, and this back end of the car is just absolutely loaded with equipment. It had a 40-core Linux cluster, which compared to the CompactRIO probably has something like 200 times the processing power. And the Virginia Tech team did better than MIT did in this competition. And so, the question of why LabVIEW, why did over 70% of the Minnesota teams choose to use LabVIEW last year, and why did Virginia Tech succeed in the DARPA Grand Challenge where MIT did not, is really that it boils down to a number of things. LabVIEW is an intuitive and easy to learn programming language. Many people have told me it's by far the easiest programming language they've ever learned. It has a logical interface, and debugging it is about as easy as anything you'll ever see from a programming language. And it removes a lot of the complexities of text-based languages. Things like syntax and memory management are all handled in the background for you. And so these are just kind of my quick rundown of why I see that LabVIEW is such an ideal language for robotics. LabVIEW gets used more and more for robotics every day. And so examples of things like FIRST, but as well as many other things that are out there, LabVIEW is being used for robotics on a very regular basis today. And so let's jump into what is LabVIEW. LabVIEW is a programming language, but is a graphical programming language, which is what makes it different. Some people refer to it as G programming, or G programming just being short for graphical programming. And so the major difference between LabVIEW and other languages is that the actual program that's running in the background, is all graphical. It's all icons and wires like a flowchart. And so all of the data, instead of going line by line through a program, just flows through the program. It makes it very intuitive to see and debug. And then there's a lot of things built into it that just make it an easy programming language to use, especially for scientific and technological activities. So things like robotics work extremely well inside of LabVIEW. So if you're sitting at a computer or sitting next to a computer where you have LabVIEW on it, you can feel free to jump over to that, to have that computer sitting next to you. I'm probably going to move faster than I would if I was teaching you in person. But if you want to try to follow along with me, you can feel free to do so. I'm going to kind of move because this is going to be recording, but if you want to follow along, feel free to do so. If not, come back and rewatch this video and pause it, to give yourself enough time to follow along with what I'm doing. So on the screen, there's three major things when you open LabVIEW, and I will show you that when I move over to LabVIEW, I'm actually going to close out of a couple of things here, and I'm going to get my splash screen. You'll notice mine looks ever so slightly different than yours. I am running the professional version of LabVIEW instead of the FRC version of LabVIEW. But in general, most of the things that I'm going to be looking at are the same. So just a heads up. But the major things I want you to see if you open up your front panel in LabVIEW are that the first thing up here is this blank VI. A VI in LabVIEW is a program. It is short for virtual instrument. And so that's the idea behind every program that you create in LabVIEW will be saved with a .vi extension. So that's just short for virtual instrument. The second thing I want you to see is that you can learn from these tutorials. These tutorials that were added in the 2011, that were linked prominently in the 2011 edition of LabVIEW for FRC, are very good. And these are actually, once you start working with hardware, these should be the first 7 things you work on. And when I get that, that'll be kind of the 4th section that I post on that website I've created. But these will really be the first 7 things that I'm going to recommend that you work on once you have the CompactRIO or your robot available to you to start programming. And then finally, down in the corner here, you have this Find FRC Examples. And that's the example finder that links all the examples that are written just for FRC. And there's some very good things there. I highly recommend that anytime you're looking to do something to add on to your robot, like if you want to add some pneumatics or something like that, go find the FRC example related to pneumatics and start and open it up and read through it, because it will do a very good job of explaining everything that you need to get pneumatics working. And the other thing that you'll know about it is that example works. And so that those examples work. So if you can't get that example to work with your pneumatics, you can be sure that you have a pneumatic problem and not a software problem. And so having those examples there is very nice to give you confidence that you're putting things together correctly. So as I mentioned, LabVIEW programs are called virtual instruments. Every virtual instrument or every VI has 2 parts to it. It has a front panel and a block diagram. For FRC, you are going to be spending vastly more time on the block diagram than you are on the front panel. Something like the dashboard is an example of a front panel. But in general, in FRC, you don't spend a ton of time modifying front panels. Most of what you're going to be doing is probably modifying block diagrams. But the front panel is the user interface. It's what everyone interacts with. It has controls and it has indicators. And then the block diagram is all the logical code that runs behind the front panel. And so, it's all of how your program's put together. So all the logic of how the robot is running would be put together on the block diagram. Or that clues you in as to what's going on would be put together on a front panel. In order to create a front panel, or a block diagram for that matter, what you're going to do is you are going to use palettes. And the way you get your palettes up is you right-click on the front panel or the block diagram to get them up. This one specifically is the controls palette, which has all of the controls that you can put down on a front panel. And so I'm actually going to jump over to LabVIEW now, and I'm going to open up a blank VI just to start showing you a little bit of that. I'm going to go Window, Tile left and right. And when I do that, what you'll see is it puts my front panel on the left-hand side of my screen, and it puts the block diagram on the right-hand side of my screen so that we can see both parts of it, at the same time. For demoing, this is the way I'm going to program. Once you start programming, I don't recommend doing the split screen approach. You should really be devoting a full screen to the block diagram most of the time. But so now if I right-click, and so I'll just do that again real quickly here, but when I right-click, I get a list of palettes that comes up, and that's everything that I can put down on my front panel in LabVIEW. And so there is a ton of different things here. But most of the ones are the ones that I'm interested in are these things that are right at the top of the screen here in the modern numeric and the modern Boolean palette. You'll see that I've got knobs, I've got sliders, I've got numeric controls, numeric indicators, I've got gauges, I've got meters. And if you've actually used LabVIEW before, or you've used the dashboard before, you've probably seen some of these things. I've also got things like buttons, so push buttons, toggle switches, rocker switches, LEDs, stop buttons, all sorts of different things that you might be interested in adding to your program. So for the moment, I am just going to go ahead and I'm going to add a numeric control. I'm going to grab a knob, and I'm going to set it down on my front panel and stretch it out just a little bit there. And you'll see, so I go ahead and I do that, and there I have a knob on my front panel. And I can, by default, it will highlight the name so I can immediately rename it. So I'm just going to call this commanded speed. I'm not sure that's proper English. But I'm going to say that as an example, that would be a speed that I might want to set my robot to drive at. And then I'm going to add a second knob here. And what I want you to see is that when I do that, I'm actually going to get an icon on the block diagram over here. So I'm going to go and grab a second knob and stretch that out a little bit and call that one measured speed. My typing is not ideal today. So measured speed, I'll pick that up and kind of center that. And so commanded speed and measured speed. And so I have created, I've created two controls. Now you'll notice as I created each of these, I got a corresponding terminal on the block diagram. And this terminal is the representation of this value in my program. And so that is the way that the value that I set commanded speed to is going to be used inside of my program. So I'm going to add a couple more things to my program now, and I'm also going to show you one trick. If you're going to be adding multiple things, instead of just cascading through the palettes and picking something and having the palettes disappear, I can instead come up and I can tack the palette down and then choose another palette that I'm interested in, and then that palette will actually stay there on the screen. And so that I can actually pick up something like an LED and set it down, and then if I want another LED, I can put that down as well. And so it allows me to add things more quickly. My screen resolution is a little down right now, so it's a little hard maybe to see this, but that can be very useful at times. In my case, I don't actually want two. I don't want two LEDs right now, and so I am going to. So I am. Let me see here.
There's a same attack on you. There you go.
Yeah, I just figured out how to do it there. So I just got rid of the tack so I can get rid of the palette there. So, all right. Sorry, just having some problems with the software. So I'm going to get rid of the square LED there. I am going to keep this Boolean, and I am also going to go grab a meter. And I'm going to stretch the meter out a little bit, and I'm going to call the meter wheel slip. And then I'm going to rename the LED wheels slipping ? And so what I'm going to do is I'm actually going to kind of compare the values between these two knobs and then display the value on the meter. You get to what I'm going to do with the LED in a few minutes here. So let me jump back to my slides quickly here. On the block diagram, you have palettes that look very similar to the ones that are on the front panel, but they have all different functions because instead of being things that are there for the user interface, they are instead things that are there for laying out a program. And so there's actually vastly more things available on for the block diagram on what's called the functions palette. So if I come back here, when I right-click on the front panel, I get the controls palette. When I right-click on the block diagram, I get the functions palette. So just two different palettes depending on where I'm clicking. Now in my case, I want to know what the difference between my commanded speed and my measured speed is. And so for that, I'm going to need to do some subtraction. So I'm going to right click on my block diagram, and I'm going to go to numeric, and then see the subtract there, grab that, and place that down on my block diagram. And so when I do that, I'm now going to wire everything together. So I'm going to come over, click once, come to the subtraction, click a second time, and then drag the output over to wheel slip. I'm going to try to keep my my wiring laid out relatively cleanly here, so it's pretty easy to follow what I'm doing. But so I've got commanded speed, I've got measured speed, I've got wheel slip, and so all of those are connected to their front panel items. And so now at this point, I've actually written a program here. I'm going to subtract one value from another, and then display the value to display the value on this meter. So if I say that my commanded speed was 7, but my measured speed was only 3, then my wheel slip should be about 4 when I hit run here. So to run the program in LabVIEW, you come up to this white run arrow, you hit run, and you'll see when I do that, my value updates to 4. If instead my commanded speed had been 5, and my measured speed had been 3, then my wheel slip would be 2. And like the opposite could also possibly happen. Maybe it was rolling down a hill or something like that. If I set it to 5 and measured speed was 7, and I hit run here, well, that value should be -2. But -2 is off this meter. So one of the nice things about LabVIEW is you can always go in and change the value, just highlight and type a new value into the bottom of the meter. You can even do that, while the program is running. So you could even rescale. The meters on your dashboard if you wanted to. So now I can see that I can display more negative numbers. So 5 minus 9 should be -4. 5 minus 1 should be 4. We see all the I've written a program here that does a little bit of subtraction. So that's kind of the very basics of creating a program inside of LabVIEW. Let me jump back to my slides here. One of the things that I'll go back to real quickly here is to show you the tools palette. And so the tools palette inside of LabVIEW, you rarely actually bring up because most of the time the mouse will will do automatic tool selection. And so I will bring up the tools palette, but this little green light on the tools palette means that that automatic tool selection is turned on. And so let me go up and go View Tools Palette. And actually, so that's not actually going to work because I changed my screen resolution. My tools palette is probably sitting somewhere over just off of the screen right now. So instead, let me just show you what this looks like. So that is the tools palette there. And so automatic tool selection with this green light on means that it's automatically going to move through these first 4 tools. So the first tool, this pointing finger, is the operate tool. And so I can pick up and I can move the value of the knobs. The second tool, this arrow, allows me to move and resize things. So if I move to the edge of something like this with the pointing arrow, I can pick it up and I can move it. The other thing I can do is once I move to that edge and I see those blue dots appear, I can move over those and I can drag that out to allow it to be bigger. And actually, I kind of wanted that bigger. The third thing I can do is I can edit the text. So instead of wheels slipping, I could have said wheels are slipping. So that's the third automatic tool. I can also pick the text up and move it around. And then the fourth automatic tool is the wiring tool. And so now let's say that I wanted to say if this value goes above, say, 2, then the wheels are slipping. Well, I could come over here and I could grab a greater than off the comparison palette, set that down, wire that into the wheel slip, wire the output, and you'll see that it automatically selects this wiring tool to wheels are slipping. And then the last thing I need to do is I need to add a value. Now, I could add a value here on the front panel, but if I'm sure that 2 is the value I want and it's never going to change, I can instead go and add a numeric constant. and just type 2 in there. And so a constant's a value that exists only on the block diagram. You can't see it from the front panel. And so that is just a value. So now I'll say that if the value is over 2, then I will consider that slipping, and I'll light this light. So in my case, if my commanded speed is 5 and my measured speed is 2, and I run this, then we'll see that that's over 2, and so the wheels are slipping. But if instead this was more like 3.5, and I run this, well, then that's not slipping. And so then my LED goes off there. And so those are, with the cursor, there are 4 major tools: operate, move and resize, text, and wiring. And those are the 4 things it's automatically going to move through. If you need additional tools, there are some other things there. The main one that people tend to use is the paint tool. So if you want to make something just awfully hideous in a really short amount of time, you can do that. It takes no time at all. I don't recommend it. It's horrendous to look at. So instead, I'm just going to hit Control-Z, which is undo in LabVIEW, and it will make it much more pleasant to look at there. Any major questions so far?
I have not seen any new questions come up.
All right, sounds great. So in which case, I'll jump back to my slides here. So the other thing to talk about within the environment in LabVIEW itself is the toolbar. At the top of the screen, we've already seen the run button. The run button will basically just executes the program. It changes to this black appearance when the program is running. A few other things to look at here. This run continuously button, I really don't recommend using this. I don't see there being any strong reason for you to use this, because very soon we're going to talk about looping structures, and they replace the need for this run continuous button. The third one is abort execution. I would guess that at some point all of you will need to abort execution of your robot. And so that's what that stop sign at the top is there. Across the top here, other things like pause, the fonts, to set the fonts up, are just kind of self-explanatory, I feel like. These resize tools up here are kind of nice. So the types of things like, move forward, move to back, and then as well as the ability to line things up and resize things equally. So if I go, if I highlight those two and I choose to make them equal widths, it will resize them equally. And then I can also choose to align the centers of them if I want to, or to align the left edges or the right edges or the tops or the middles or whatever. If I go vertical, obviously that doesn't work very well when they're on top of each other. If I want to take out the spacing between them, I can go to 0 space, move them right next to each other. Just some things to make it a little easier to move things around. So those are pretty self-explanatory. Some of the more useful tools, I feel like this light bulb is called highlight execution, and it's probably one of the very useful things inside of LabVIEW if you're having trouble or you're trying to debug. If I come up here and I hit run here, this will actually slow down the execution of my program, so I can actually see the values flow through the program. So if I hit run here, you'll actually see these values flow through my program. I'll do that again. So you can actually see what the math that's happening there on the block diagram. So highlight execution slows down the execution of your program.
So Jed, there was a question about how do you compare the number to a variable? So instead of a constant, how do you compare to a variable?
So if instead of a constant you wanted to have something on the front panel, what you would do is you would create, you create a value like this, an additional numeric value, and instead of wiring in the constant, you would wire in, a numeric like this. If you were doing a calculation in your loop and you actually wanted the output to be part of this comparison, you would instead just wire that directly in. Instead of wiring in a constant, you'd either wire in a front panel control or you'd wire in some other value from your program. If that doesn't clarify, just please ask a second question.
Great, thank you.
Sure. Yeah, so I guess last thing here are these step function buttons. And so the step function buttons allow you to step through the program one step at a time. And so when you just have a small program like this, all they do is just, all the buttons basically do the same thing, they just step through. If you have a larger program that has sub-PIs or sub-programs, you can actually choose whether to step down into the lower level programs or to step over lower level programs with the different buttons. But basically all of these allow you to move through the program one step at a time. So let's jump back to the slides here. So I've got reminders to myself: opening LabVIEW environment, toggling. I'll show toggling in second, palettes, placing and aligning, wiring, creating structures. So two more things I want to go over before we leave here. I'm going to talk more about them in a minute, but the first thing I want to talk about is a while loop. A while loop is a pretty key structure, and I'm just going to right-click, go Structures, While Loop, and I'm going to wrap this around everything in my code. And what this is this is a structure that says I am going to loop this code over and over again until this condition is met. And this is a stop condition down here in the corner. So the most common way to stop it is to go to the front panel and create a stop button. And so I'm just going to do that for right now. So I'm just going to take that, put it in my loop, wire it to my stop terminal, and at this point, instead of just my program running once like it was before, I can now run in real time. And so structures, the structures in LabVIEW are the things that are going to allow you to create larger programs. And so we can see what it's going to take. We can see that my wheel slip light turns on in real time here. So this is probably not all that dissimilar to what your car is doing when it's not getting traction. It's making a decision and lighting a light. That slip light, fires at, lights up in your car. Something not all that different from what we're seeing here is probably happening inside of it. Once we're done in the loop here, we hit stop. The program stops executing, and now it's not updating in real time. So. The other thing I wanted to show you is there is a shortcut. Like I said, I split my screen, but what I normally recommend doing is doing any development with your block diagram full size, like this. And if you're doing that, Control-E is a shortcut on the keyboard that lets you flip back and forth between them. Control-T will put them back to side by side like that. Control-Z, I think I mentioned earlier, is undo. So those are kind of key ones. One of the unique things about LabVIEW, Control-Y is not redo. If you're a big keyboard person, Control-Shift-Z is redo in LabVIEW. Let me jump back over to my slides here. So those are kind of the things I wanted to get through in this first section. So next I'm going to talk about data types. If you notice, I have 3 different colored wires in my LabVIEW program, and that is because they are each different data types. I have this green wire. It is a Boolean. It's true-false. I have these orange wires. These are floating point numbers, and so that means they have decimals associated with them. This blue number is a fixed point number, meaning it does not have a decimal place associated with it. So if you'll notice, actually, if I click on here, and instead of making this 2, I make this 2.5, you'll notice it immediately turns orange. Because now it can no longer be a fixed point number. It has to not, once it has that decimal place, it has to be a floating point number, and it changes orange. If I liked it as a fixed point number, it doesn't really matter. I can hit Control-Z and go back to what it was, and then you'll see it turns back to being blue. So major data types inside of LabVIEW here. You see blue, orange, and green are the ones we've seen already. You will also see lines will get thicker as they carry more data. So if they're carrying arrays of numbers, the lines will get thicker. And then if they're carrying groupings of data, which would be a cluster, you'll see these thick pink lines. And we'll talk more about clusters later and in a future session. So that is data types inside of LabVIEW. Next thing I want to talk about is data flow. LabVIEW is a data flow programming language, which means it does not execute top to bottom. It does not execute left to right. What it does is it executes when all data is available, which is sort of a unique way to become used to working inside of LabVIEW. Because waiting for data to become available is not a traditional way of a programming language executing. But once you get used to this, it will make a ton of sense to you. And so the basic idea is that if you look at this top section of code here with A, B, and the result, in order for this, working backwards is probably easiest. In order for this result to be updated, it needs to have the output of the multiplication. In order for the multiplication to be updated, it needs this 2, and it needs this addition. And in order for this addition to be updated, it needs A and B. And so what you can see is that A, B, and 2 aren't dependent on anything. They're just immediately available. So at the time a program starts, A and B will arrive at the addition, and the 2 will arrive at the multiplication. But the multiplication is still missing a value, so it can't finish running. It still needs this addition to finish. So once the addition finishes, it moves to the multiplication. Once the multiplication finishes, it moves to the result. And you can actually visualize this really well with that highlight execution that I showed you earlier. So if I hit run again here, you can actually see those numbers flow through the program. And then it'll loop back and it will run again now that we're in a while loop. So what you'll see is, if I move these, we'll see new values will arrive, and the math will change, and the resulting program will change. So something to notice about highlight execution, it's not just visualizing it more slowly, it's actually running the program more slowly. So this isn't a way to debug in real time. It's debugging in sort of real time. It's quite a bit slower than the program would normally run. So jumping back to the slides here, if we look at this as a whole, the one thing about data flow is at times you'll have code that's not dependent on each other at all. And so if you'll notice, this bottom section of code here is not dependent on anything from this top section of code. And so as a result, there's actually no way to say which chunk of code might finish first, whether the result would update first or the waveform graph would update first, just from what we know right now. And that's okay. There are times when you might have to force execution orders, and there are some things that you can do in LabVIEW to do that. But most of the time, letting it execute on, as data is available is the most efficient way possible to have LabVIEW execute. And so this is, just to give you an idea, your data flow, if there's no data dependency between two sections of code, there's no way to say which one of those will finish first. Looking back at our program, what we can say about our program is that the output of the subtraction flows to the greater than. So we know that the greater than can't execute until the addition completes. And then wheels slipping can't be updated until the greater than finishes. And as you watch this flow through, that's exactly what happens. Commanded speed, measured speed flow to the subtraction flows to the greater than flows to wheels are slipping. Any questions on that at all? All right.
Doesn't look like it.
Sounds good. A few things to help you with debugging in LabVIEW. I've already shown you highlight execution, but one thing is that LabVIEW does very well is highlight where errors can be found. So I'm going to jump back to my LabVIEW program here. I'm going to turn off highlight execution and stop my program. And I'm going to go ahead and I'm going to delete this wire. And when I do that, if you'll notice, my run button up here at the top, it can no longer be pushed. And so that means that, but now if you'll notice it says list errors. So if I hit that, it will actually list everything that's wrong with my program. Subtract contains unwired or bad terminal, wire has loose ends. If I highlight it and hit show error, it will show me exactly where that is. Wire has loose ends, it'll show me where that is. And so if you actually come here and wire these back together, you'll see that fixes both of the errors and they both disappear. So LabVIEW is very good at highlighting what's wrong with your program for you. The other thing on that page is probes. And if I right-click on a wire, I can put down a probe on that wire. And I believe your watch window in your version, your FRC version, a little bit different than this, but it's about the same. When I hit run, now with the probe window open, the code still executes at full speed. So it's not slowing down the code like highlight execution, but it still allows me to see this value, see the value of that without having to slow down the execution speed at all. So that's what the probes are used for. So that's just another one of the debugging tools inside of LabVIEW. Another thing that's helpful inside of LabVIEW is the context help window. Common question when I use something like a subtraction is which value gets subtracted from which value? Well, if you go help, show context help, or if you hit the little question mark block on the upper corner, this context help window appears. And then you can go hover over something like the subtraction. Like subtraction, and what you'll see is that it tells you that the inputs are x and y, and the output is x minus y. On the greater than, the inputs are x and y, and the output is x, is x greater than y is the output question that's being answered. And so context help allows you to get details about the things that are on your block diagram. Even something like the while loop you can hover over, and it will tell you what the while loop does. On all of these, you can also click for more detailed help, where it will dive more into the details of how something works. Control H is the keyboard shortcut for that. So Control H will allow that, will allow you to pop that up or shrink that back down. So I think I've hit almost all of these. Control R to run the VI. I did not talk about Control E swaps between the front panel and block diagram. Control H turns on context help. Control B removes all the broken wires on your screen. So if, for example, you end up deleting something like, say the subtraction, and it leaves a bunch of broken wires and you want to get rid of all of them, Control B will do that. Once again, Control Z is undo. So if you want to leave them there, you can do that quickly. So those are just, we'll talk more about some of these, and I will provide links to some of these tools, CompactRIO imaging tool, tools, setup, access camera, tools, options, things like that as time goes on here. One of the major things that you'll use inside of LabVIEW I've already shown you, which is the while loop. And the while loop runs until a condition is met. The other major loop inside of LabVIEW is the for loop. A for loop runs the number of times you wire to n in the upper corner here. And so that is the difference. The while loop runs until a condition is met. The for loop runs a certain number of times. And so both of them have the I down in the corner here. And the I is the number of times the loop is run. So I'll show you that real quick, and then I will add a for loop to my program. So I'll just pick this up to make a little room. I'm going to go grab a numeric indicator and put that down on my screen. Make it a little bit, text a little bigger there. I'm going to put that in my loop, and I'm going to hit run here. And the main point in adding that, for you to look at is to point out to you that LabVIEW is a very, very efficient programming language. It's it runs very equivalently to the way that a language like C or Visual Basic does. It's quite a bit faster than a language like Java, and it's immensely faster than like an interpreted language like Ladder Logic or MATLAB would be. LabVIEW, at the time you hit run, is a fully compiled language that compiles down to machine code. And it has specific timing constructs in the way that it runs. And so if you'll notice, in the amount of time you watched me run there before I hit stop, we ran 43 million times, which brings up a point that there's not a lot of value in running a calculation like this 43 million times. And so you're actually eating up pretty much all of the available processor cycles to do something like that. So it's a good point that you may want to add a time delay into your loop. So I might want to grab something like a wait statement and then create a constant. This is a shortcut, by the way. If I right-click on the input, I can create a constant and type a millisecond, a number of milliseconds, so 100 milliseconds of delay. And so now instead of running 43 million times in 5 seconds, it will run 10 times a second. So now I still get really nice responsive updates of the screen. Like there's no lag at all in the way that the screen updates. But instead of running 43 million times, it ran 84 times. And so that's freed up 43 million calculations to do something else in your robot. Something that you definitely want to pay attention to. You want to time your loops inside of your programs. Most things that come with the default project will have things like this already built in or will use timed loops, but this is something to watch out for. If you're ever losing communication with your robot as your program starts running, it's not all that unlikely that you might have a loop that's running unbounded like this, that's kind of hogging up all the time that should be being used for communication back to your computer. So that's one loop. The other loop I was going to show you is a for loop. And so I'm going to set a for loop down here, and I'm going to right-click and use that shortcut again and create a constant of 101. And I'm going to add a progress bar, which I will call loading ... to my front panel. And I don't see it. Oh, yeah. So you can always click on the front panel item to find the block diagram item. You can find the block diagram item by clicking on the front, or the front panel item by clicking on the block diagram, or vice versa. So I want to move that up here. And I'm actually going to connect this to my iteration count. And the other thing I'm going to do is I'm going to add a delay to that loop. And so there's a shortcut you can use where if you highlight something like this and hold down Control, you can drag it and it will make a copy. So the Control drag will make a copy of something that's highlighted. And you can do that with just about anything in LabVIEW. So you can do it with something like this and just make a second copy, and you'll see that appear down at the bottom of the screen there. I'm going to Control Z because I don't actually want that one. So now I actually have two loops in parallel here. So if I hit run, these two loops will execute independently. So if I hit run, what we'll see is that I can do my math up here, and my progress bar is loading at the bottom there. And so once this gets to 101 iterations, which this displays 100, that will stop at this point. This loop is no longer running, but my for loop continues to run because the for loop runs until a condition is met. So I can hit stop there. But one of the nice things about LabVIEW is when you want to run two things in parallel, all you do is just put a second loop out. If you want a third thing to run in parallel, I can use my Control drag trick and create a whole nother loop like that. And now I have three things that will run in parallel. I don't actually want to do that right now, so I'm going to hit Control Z and undo that. But just adding an additional loop causes things to run in parallel in LabVIEW. And it will automatically set up multi-threading in the background to take advantage, to make sure that the loops run independently. Now, one thing I want to show you now is I want to revisit the topic of data flow, because before I showed you that data will flow, that something has to wait until data is available to it before it can start. And so I'm going to grab this wire, and I'm going to drag it out of the for loop and connect it to the edge of the while loop. And so what I'm doing, so now I'll just run this and I'll show this to you. The progress bar is loading, but what you'll notice is while I can change these values, the measurement isn't updating. See, my needle's not moving until this finishes. And as soon as that finishes, then my while loop starts running, but not before. And the reason why that is that this while loop, even though it's not using this data, is now dependent on it. It is waiting for that data to become available before it can start. And so this is the way that code is frequently set up, where you have like a begin VI, a main VI, and then maybe you'd add another structure that was dependent on this one, this main VI, that would be your shutdown or your close VI. It's kind of the same structure that the FRC framework uses. And so I'll try to show this to you with highlight execution turned on. I'm going to hit stop here. I'm going to hit start, and I'm going to let this fill almost all the way. We'll see how quick my reflexes are. In just a second here, I will go ahead and I will hit to turn on highlight execution. We'll see number 98, number 99, number 100, and the number 100 is the very last one, and at that point, it moves down, and then the while loop can start. But not until this loop finishes can this loop start. That's the construct of data flow. That's how data flow works. It is dependent on having this data available before this structure can start running. Any questions on that?
There are none. There was a question about the positioning of the wires. Does it matter which one's on top or which one's on bottom?
The wiring does not matter. You know what the wiring does not. Every wire has an input and an output, but it does not matter where the wire is on the screen. So I can take, instead of having this wire look the way where it does, I can take and make my wire, every time you click, it will sort of tack the wire down, and so I can do this, and the wiring doesn't matter at all. I can do just about anything I want. I can have it go under something. I can have it go around something. The wires data flows, every wire has, data can only be placed on a wire from one location. And so like on this wire, the data is coming from here. It can go to multiple locations, but data can only be placed on a wire from one location. And so that will always determine, how data moves through the wire. And there is a shortcut where you can right-click and clean up the wire, and it will kind of reroute it for you in what it considers the most logical way.
And can you change the incrementation? The increments in LabVIEW for the loop, or with any loop that doesn't just count the you can't change the loop itself. The I just counts based on iterations, but you could easily grab something like a multiplication and add a constant of 2 or 3, something like that, and then wire my program is getting a little tight there, but just wire that in that way, and now this value would be incremented 3 at a time instead of one at a time. But the I, you don't get to change the properties of the I. The I is going to count the number of times it's run. What happens when you cross a wire over?
So if a wire is joined, the dot will appear there. But so I can take this this wire, for example, and cross over as many different wires as I want, and this won't affect the way that it works at all. Because if you'll notice, that little junction dot doesn't appear at those locations. It is not it's not connected. It actually, even if you really zoomed in on it, it'll actually see that it even creates a little bit of a white space, kind of like you would show a highway on a map, to show that those two are not connected at that point.
All right, that seems to be it for right now.
All right, so I'm just about done with trying to go over my basics of LabVIEW, and instead I'm going to go to the additional resources that I want to point you to. So I added a for loop, I created a loading bar, I discussed data flow, and I discussed parallel loops. So those are kind of the major topics I wanted you to see there. I'm just about out of time, so I'm going to skip these last 2 topics. They are things that are going to be covered in the things I'm linking to. So additional resources and next steps. I've just created this page today, and I really am hoping that you guys are going to take advantage of it. I think this is going to be a great way to put material out there for you. Instead of trying to lead more sessions, like we've done a lot of in-person training the last couple of years, I'm happy to do more online sessions in the future, but I also want to put a lot of material out there for you to work through on your own. And I've tried to lay it out in this very logical form, where on this page, I'm going to go to the page here, and once again, ni.com/mnfrc. So I will, that's the kind of the vanity link. It will come up much longer, but ni.com/mnfrc is the the vanity link for it, and then you get the long, ugly one afterwards. Like I've got 3 things that I posted. I have this main thread, so kind of start here, and it gives me kind of a summary of what I'm trying to do here. But then you'll notice I have section 1 linked and section 2 linked, and I have plans to put up 5 additional sections. A section 0 for the Help I Know Nothing, all the way down to Intermediate Advanced Robot Programming in section 6. And so, like, these are all other sections that are here. So, for example, I can click on section 1, and what you'll see when you go there, as this loads here, is there's a step. My step 1 is I suggest rewatching the training and building the example on your own. If you prefer to get the same type of information, you can use alternative step 1 below. So I've got 5 little short videos that I link to on our website that cover the same type of material that I just covered live for you. Step 2 is to go watch these 2 videos at an external website called frcmastery.com. And this is actually one of the very best resource websites for learning about FRC. He doesn't have a lot of material on the very basics of LabVIEW. So beyond these there's only a few videos about the basics. He does really, really good work on the advanced topics. And so I will link more to these as I get into some of these later sections. And then 3, your task, I give you a task to build a small program that does a little math. Not all that different than what I've kind of walked through with my wheel slip example. But I actually want you to build it yourself. And so then, if I come back to the Minnesota First Robotics page and go to section 2, I once again have a few more videos. A video on a topic called the state machine, and then a quiz and a project that you can work through, and then finally a longer video on a state machine from frcmastery.com. And so these are, there's some ways to check your knowledge with the quizzes and the projects, but these are things, if you start working through these now, before the season starts, by the time the season starts, you're going to be really, really well equipped to build a really good robot. A lot of the times I see people not trying to learn how to program in LabVIEW until middle to late January. And if you're doing that, it's not awful. You're still going to probably, you're going to work out, it's going to work out okay for you, but you're never going to create a great robot if you're just trying to teach yourself LabVIEW halfway through the build season. LabVIEW is, teaching yourself LabVIEW ahead of time is one of the things that you can really, really easily do ahead of time. And so that is, kind of what I'm trying to do with this page. So I'm going to ask you to please come to this members page, and sign a mentor and a programmer up, or one or the other, and then opt in to receive emails, because then if we do future training sessions, I'm going to be able to send out information about that. So go ahead and join the page, and then come and take a look at these discussions. Please leave feedback on these too. Let me know how they're working, because I think that I've worked hard to find really good material for you. But if you don't think it's very good, let me know, and I'll try to find different material to link to instead. So just want to point that out to you. So ni.com/mnfrc. So that's about as easy as the link can get. A few other things. There is technical support. If 1 mentor and 1 student per team have access to technical support, that doesn't start until the build season starts. Up until then, you're just going to be things like support forums are still open. But once the build season starts, tech support's open, I believe, 1 to 7, Monday through Friday. The majority of teams don't take advantage of this, and they can't. If you have questions about LabVIEW programming, National Instruments, once again, we very much support this first program, and so we have, we put a number of applications engineers to answer phone calls just on supporting FIRST-related topics. In addition, from that same phone number, you can get an expedited RMA of your hardware. That's a return material authorization. That's if you break your hardware and you need a replacement. So that's, that number works for that as well. And then you can also use that number to purchase the extra CRIO if you want to. Other resources that are out there, and actually I tend to link these from that ni.com/MNFRC page, but ni.com/first has a number of things that are available. I link to a number of their resources. And then the first web page, the academic web page, the Chief Delphi forums, and then the frcmastery.com. If you've not seen this website before and you've done a little bit of LabVIEW programming in the past, you really should go take a look at this frcmastery.com and watch the videos that they put out there. This is a guy who teaches LabVIEW to industry for a living, and he is the mentor of a first team, and so he has put up some really, really good content. I will be linking to it from that MNFRC page as the season goes on. Oh, I forgot to even put the nice little vanity link on this page. So, to wrap up here, remember, learning LabVIEW is one of the easiest things that you can be working on before the build season. Too often I see people doing it after the build season starts. You're best off learning to program in LabVIEW now. It will allow you to do so much more with your robot as the season goes on. Lead programmer in your team, if you can get them 10 to 20 hours of programming, they will be in great, of experience before the season. They'll be in great shape. And then I guess in terms of just programming for programming, nothing's better than actually opening up examples, running them, interacting with hardware. You really can't screw up the software and controller aspect of it. The only way you can screw up the controller is to get it, is to dunk it underwater or to get metal filings into the openings of it. So as long as you're covering up the connectors and the Ethernet ports on it when you're doing work around it, you really can't screw up the controller. That's not true once you have hardware connected to it. Once there's wiring and electricity involved, you can definitely screw up the mechanical components of it. But you really can't screw up like learning to program inside of LabVIEW using the FRC examples or using the FRC tools. Finally, one last time, I forgot to update this link to the new short link, so I'm going to just jump back to that page. So finally, to wrap up here, ni.com/MNFRC, I will put my slides up there later tonight. And I hope to have a few more advanced sessions on LabVIEW in the future. So, definitely sign up so that we can contact you when those are going to happen. Any questions as I'm wrapping up here?
No, there aren't any. Thank you very much, Jed, for your time.
Sure. So, good luck to everyone this season. As things come up, definitely take advantage of the